Now, with that, I'm going to turn it over to my good friend, longtime friend, and colleague, Adnan Khalil. Today, we're going to talk about anti-gravity, and we actually have a second session about anti-gravity coming up on August 4th. Today's session, he will explain the breakdown of the content today, and then at the end, we'll talk about what's coming up in 4 weeks on October 4th. So please welcome Adnan Khalil with applause. Thank you, Adnan.
Thank you very much, Jay. Hey, welcome to everybody in the community. Greetings wherever you are. So as Jay mentioned, I'm part of the HPC group at Google over here, and I work with Jay. I've known Jay for a very long time. And today I'll be talking about one of Google's many AI tools, and this one's called Antigravity. And the way I've structured today's session, there's going to be a lot of live content, so please forgive me if something doesn't work in advance. Before we dive into the live stuff, which is really quite exciting, and I've got several problems from molecular dynamics to like physics, three-body problems, writing MPI code, matrix multiplication, and all of that stuff. And we'll see how much of that we actually get to. But I want to give you sort of a brief overview of what anti-gravity is. Okay, now, for those of you who are not familiar, and let's just a quick sort of thumbs up. If you've worked with anti-gravity, are familiar with it, have you downloaded it, just give a thumbs up. Let's see how many folks that we have. So, okay. So it seems like quite a few number of folks on the call have already worked with anti-gravity. That's great, right? So what is anti-gravity? And it started off as one sort of tool. It's sort of, as it's grown and matured, it's broken up into several tools. But let's just quickly walk through that. And today, what I'm going to be covering is the IDE portion of it, which is the Intelligent Development Editor. And that integrates, an agent, it integrates the command line, and everything that you'd expect from a modern IDE. So, that's really what we were talking about today. So what is anti-gravity, right? So it is really, an agentic platform from Google. It incorporates Gemini. And allows anybody to build anything that you'd like, and that's what I'll be demonstrating today, right? There's several things that you can do with it, but at its core, anti-gravity is four things. You have the anti-gravity, the app itself, which is kind of like the orchestrator. You have the anti-gravity IDE, the integrated development environment. Then you've got the CLI version. Now that's what I'll be covering in a couple of weeks. I think August 4th, I believe, and we'll dive into what anti-gravity CLI is. For those of you who are familiar with Gemini CLI, it's kind of morphed into this anti-gravity CLI. And last but not least, you've got the SDK that allows you to integrate the anti-gravity capabilities into your own applications and apps and so on. So that makes it really much more powerful than it is on its own. So the way anti-gravity works is, it's a truly agentic workflow now, and I'm sure most of you, and almost probably every one of you, have interacted with an LLM. Now you ask an LLM a question, it'll give you a response to that question. It'll do some searches and things of that sort. Now, anti-gravity is really taking that to the next level. It is truly an agentic workflow. In other words, if you ask it to do something, it'll figure out all of the intermediate steps that are necessary for it to get it done. It'll plan it out, and then it'll sequentially go and try to do everything as part of its plan. And ultimately, it'll verify stuff. Now, to give you, what does this mean in practice, right? And we've got a demo on this in a moment, but, let's say you're writing some code to do C++, and you're trying to do a matrix multiplication. Well, you can say like, hey, generate a simple matrix multiplication code for me in C++. And it'll figure out, what exactly it needs, and it'll spit some code out. And then you can ask it to optimize it for a particular architecture or things of that sort. And it'll do all of those things without you having to explicitly touch any of the code. And it's all done through prompts. So like, the vibe coding aspect of stuff. And you'll see this, right? Anytime you ask it for a complex task, it'll plan it, it'll then act on it, it'll verify it, and then it'll summarize everything and it'll give it back to you. Okay, so today we're going to be talking about the IDE. And before we dive in, there's so many sort of neat little things that I think you should be familiar with, because it's really easy to not know they're there, and you only sort of, you know, require these things every once in a while when you run into problems. But I just want to talk about some of these things up front, so that when you start using it, you don't have to wonder, you know, how all of this works. So let's try to go through a few slides. You know, there's like 20 or so slides. I'll try to go through them as quickly as possible so we can get to the hands-on demo. But it's based on Visual Studio Code. Now that's an open source project by Microsoft. It's in an IDE. You've probably used it in the past or even like currently. But Antigravity really integrates that Visual Assist code editor with the agentic capabilities and so on, and you'll see that. And it has everything that you'd expect from a modern IDE. It's got like autocomplete, you know, it'll make code suggestions, it'll do all of those things that, you know, you're used to. But and here's a quick look at what that IDE looks like, right? On the left-hand side, you know, you see your Explorer and you see all of the files associated with that particular workspace. In the middle, it's divided into two halves. The top half is your code, and it's tabbed, so you can always have multiple, you know, files open. The bottom part is where you have your terminal, the problems, you know, the outputs, the debug console, and so on. And then the agents on the far right. You know, everything that you see over here is your agent. You can treat it like an LLM, but you can also give it instructions. And, you know, and the cool thing about this sort of the way, you know, how Antigravity pulls everything together is I can select pieces of code and I can ask specific questions off this code to the agent, and it'll understand and it'll, you know, do those things. Okay, so yeah, as I mentioned, the AI-powered IDE, you've got the terminal at the bottom, and you've got the agent on the right-hand side. Now, again, you know, we are Google, we are a Gemini shop, but you're not restricted to only using Gemini models. In fact, you can use whatever models you like. And on the agent side, you know, you can pick the different types of models. Now, obviously, it comes with these sort of, you know, listed, but you can include your own models and use those as well. So you're not sort of tied to anything Google in that perspective. Now, very quickly, you know, there's autocomplete as you're typing stuff, you know, based on what you're trying to do. You know, it will, you know, complete the link. I mean, it'll complete the code, and, you know, I'm sure this is something, you know, we're all familiar with. And, you know, when you're trying to explore code and understand, you know, what function leads to what, you know, you can always like jump to that function and you can sort of explore it and understand it. And yeah, and, you know, here's the other thing, right? So oftentimes as you're writing code and, you know, you think you've included a particular function, you know, you'll get those red squiggly lines underneath saying that, you know, this is incorrect. And you can ask it, you know, why is this incorrect? And you can also ask it to fix it. So you don't have to really do much beyond that. So another cool thing is, you know, when you're trying to like run your code and it doesn't find something, you can just sort of select that and you can send it to the agent. So that way you don't have to like type stuff out again. It just makes it really that much more efficient. And similarly, you can also look at your, you know, your runtime errors, and you can select all of that, send it to the agent, and it'll, you know, analyze that for you as well. Okay, so you know, I talked about how Antigravity really works behind the scenes, right? You know, it creates like a task list, an implementation plan, and a few other things. So let's go through this really quickly. You know, again, the same slide: the plan, the act, and the verify. So, you know, anytime you give it sort of an instruction, you know, Antigravity will create a task list. And this is a list used by the agent to keep track of everything that it wants to do in order to be able to solve the problem. Now, this task list might change over time a little bit, but it's ultimate, you know, but it's really the starting point for everything that the agent wants to do. it might have like 5 tasks, and it'll go through those tasks sequentially. If it thinks it can do it sequentially, you can also ask it to do it, spin up multiple agents for a task, for tasks that can happen concurrently. So in that case, it is truly, multi-agentic in that perspective. And you don't need to interact directly with these tasks lists. It'll do it for you. And you'll see when I run the demos that, a lot of the times it's having a conversation with itself. Sometimes you'll catch, bits and pieces of that conversation, and you'll see like, it's like, hey, wait, you said this, you're going to do this in the previous step, but you didn't do it. And then it'll like, oh, okay. And then it'll go ahead and do that. So it's actually quite insightful as you go and look into that list of, what it's planning to do. Now, in this particular example over here, you're just creating a simple Python Flask-based to-do list application. That was a request, and it's thought about what it wants to do. It's analyzing. It's trying to get some understanding of where it is in your directory structure and the workspace, and it's created this task list at the end of all of that. And you can see what those tasks are. And if you go and click on that, it'll say like, okay. So it creates some intermediate documentation, so some markdown files, and you can see those in your thing. And as it's going through and sort of refining its approach, or changing its approach, it'll update these documents. So at the end of your entire sort of process, you can go back and look at everything that it did in order to achieve that objective, right? So so for this simple to-do app, it's come up with the requirements. It's come up with the app structure using Flask. It's got like a data model based on SQLite, and it's got a few other things that it wants to part of the app design. And it's also got the final step, which is verification, run and test. And that's really cool, because when it does that, it'll if it's a website, or if it's a GUI, or any kind of like app that you create, it'll actually launch it. It'll sort of click on all of the buttons. It'll make sure that things are working, and you'll see that in action in a moment over here. So once it's got, the task list, is the next is the implementation plan. And here is where you really see the agenticness of Antigravity, come into play. Because, for example, as we said in the previous case, you want to do a Python to-do, a to-do app, right? But in its very first step, Antigravity might realize you don't have Python installed. So it's going to then, run all of the checks it needs to make sure Python is installed. If it's not installed, it'll go ahead and install it, make sure it has all the libraries it needs in order for it to build the app, and so on. And one of the slightly scary things I will say is, because it has so much power over your system, it'll always ask you, before it proceeds, and it'll give you like what it wants to do, and you'll see that over here, right? So here's the implementation plan. It's telling you I've created the plan for the app, and it'll ask you proceed. And sometimes this gets quite cumbersome, because it'll ask you to proceed before it runs any command. And there is a setting. I'll show you that here. Actually, just a moment. Oops. Yeah, let me share my screen. And okay, so there's multiple windows over here. But if you go to the place where it says settings in the right bottom corner of your IDE, you've got these all of these settings you can pass on to your agent. One is the auto execution, and you can ask it to always proceed, or ask it to request a review. And you can also what is the review policy, right? And you can give it all kinds of instructions over here. But if you generally trust what your agent is doing, you know, you can, you know, sort of like, you know, let it do its thing. Mary, I think I've lost my slides. Would you mind sharing them back again? Ah, thank you. All right. Okay, so so that's the proceed where it asks you for permissions, and you know, again, more details, everything that it wants you to do. And it's a good practice to review it if you've never done this before. Once you've got a general level of familiarity with, you know, how things proceed, then, you know, you can then, you know, do some of those auto execution things without it sort of, you know, introducing too many stop gaps into your process, right? So one of the main things, again, you know, it's no surprise the IDE is where you look at code, and you know, it could be anything from C++ to Python to HTML code. It'll, you know, and you may have some existing code. Now, in all of the examples that we do today, I've asked it to generate that code, so I don't really care too much about, you know, preserving something that I've created, but there might be times when you ask it to optimize some code where, you know, you want to explicitly, you know, review everything, and you'll see this come up, that anytime, you know, it decides that it needs to make a change to the code, this window will pop up and it'll ask you with these blue little things like accept this change or reject it. Now, some cases, you know, in most cases you'll probably want to accept it, but in some cases there might be some behavior that you're trying to preserve and you want to reject it and not sort of, you know, let it make any changes over there. Okay, and you know, and a walkthrough is, again, you know, this is a summary of all of the changes that it's made. It'll take screenshots. It'll do like browser recordings to verify that the changes have indeed been implemented. And you know, again, it's really amazing to see how it's capable of doing all of these things. Now, again, I've been, you know, working with large language models and so on, but to me, the fact that, you know, it can do all of these things without very much user interaction is just absolutely amazing. So okay, so I think we've gone through enough of the text. Now, one of the things, you know, this is a live demo as much as possible, and you know, and I'm sure all of you know that large language models and agents aren't exactly deterministic. Now, and as much preparation as I've done to make sure that everything happens according to what I'd like it to do, there's still some, you know, a lack of determinism there, so things may not work exactly. But in which case, you know, I've tried to create what is an output, and you know, I'll try to demonstrate that with you. So what I do want is, you know, for the audience, like, give me a simple problem that you faced on an everyday basis. And, you know, if we have enough time in the end, when it comes to high performance computing, you know, something that you've been trying to solve, it takes a very long time. And, you know, put it into the chat. If we have enough time towards the end, I'm going to try to do it. Okay. So with that, I am going to share the anti-gravity screen, and please let me know if you can see this. And for the very first one, we are going to do a simple matrix multiplication. As you can see, I've got several demos lined up. Okay, so for the very first one, and this is something that I, you know, mentioned right at the beginning of, so let me make this, maximize the size of this so you can see it. Can everybody see my screen? Okay, so this is going to be a problem I'm going to solve in two parts, right? One is I want to create a dense matrix multiplication in C++ using OpenMP for parallelization, right? And I've already sort of queued up the prompt. Let's go ahead and launch it into this thing. And now what you can see that's happening is it's working, and it's kind of going through like that internal monologue and everything that it wants to do. And you can see, it's asking for my permission. It wants to do stuff. Oops. I don't know, it seems to have run. Okay, anyways, it's produced some code. It's doing something. And again, if you noticed, all I said was, matrix multiplication, C++, OpenMP, and that's it, right? I haven't asked it, I haven't given it any other instructions. I haven't told it anything else. Now, in a previous, when I was testing this out, I already asked it to do this once previously. So now it wants to like override it, or it's trying to do something, but again, it needs my permission, but it's creating this code from scratch. And let's see. And if you noticed, what it's doing over here, again, it's really hard to keep track because things just scroll by. It is actually compiling the code using G++. It is looking at its performance, and you can see over here, what it had to do. Okay, and let's see, let's look at sort of. All right, so now you have this matrix multiplication code that was written purely from the agent's perspective, and it's even done like a simple verification to verify its performance and so on. Now, the other thing I would like to do now, and again, it's done a fairly sophisticated implementation using C++ templates, and we don't know how optimized this is, but it's the simple. For those of you who've written this by hand, it's multiple nested loops. It goes through the x and y of the matrices, and it multiplies them, adds them, and so on. Right. Okay. So the next thing I would like to do. Oops, and you can see my windows. Let's say, for example, I know I'm going to be running this on a particular x86 architecture. For example, it could be an Intel, Sapphire Rapids or an AMD Turin. And you want to make sure that whatever you do fits within the cache hierarchy of that particular architecture. So what I'm going to say is I want to optimize this code so that it's delivering the best performance for an AMD Turin. Right now, I have not specified, what exactly I mean, but it probably understands that I'm talking about the cache hierarchy, the memory hierarchy of the Turin. It also knows that Turin has some special instructions that it can use. Now you can see it is going through and it is making the changes. Now, if I'm not wrong, it's probably going to ask me for like, okay, I need to make these changes to the code. And it's also looking at the compiler flags, and it knows which of the compiler flags and which instructions and so on that it can use in order to be able to get the best performance. And so you can see over here, right now it's gone and said, okay, in order to be able to optimize this for an AMD Turin architecture, I need to make all of these changes. Now you can go through the code and it's like, okay, it's vectorized a few things. It's changed some other pieces of code to like go through and do stuff, and it's asking for my permission. Do I want to accept these changes or not? And I'm like, sure, let's do that. And now, now that um, we've made the changes, let's and it's telling you like, it got like 20.3 gigaflops on a much larger 20 by 1024 by 1024 matrix, and it's significantly better than the unoptimized baseline version that it showed you a bit earlier. And it's also telling you that it added 69 lines of code, deleted 27 lines of code, and you can review that. And and you can see what all of those things that it should, like a traditional diff that you would do, and you can see that right now. I don't know if it makes sense over here, but one of the things that I really like is, for example, if there is some lines of code that I particularly want to optimize, you can just select it. And oops. Oh, this is not it. Oh, I guess I have to do it in the code. Sorry. So yeah, you can select code and you can pass it on to the agent. You can, put it onto the chat, and you can ask it like, what is this code doing? Oops. Nice. Right. And you can ask it to explain the behavior of a particular lines of code. And again, this is fairly simplistic. It's allocating some memory, it's getting the time, and so on. So this is, and and it'll give you a full description of everything that's happening over there. Okay, all right. So this was a fairly simple sort of demo. Now I'm going to move on to something a bit more complicated. Let's see. We've got several ones. Okay, let's go on to, MPI code, right? Now, for those of you who, for those of you on the call who worked on HPC systems, message passing interface, like, that's a way of parallelizing code and running it on multiple different nodes and processors, and you typically do this, for all kinds of HPC applications, right? But because it's, it's a lot of this communication is happening asynchronously, it really is a bit of a problem to debug. Okay, so what we're going to do right now, I've generated all of these things previously, but for the sake of this one, let's kind of redo it again so you see what exactly it does. All right, so, and let's start a new prompt. And to keep things simple, let's just say again, I would like to generate a multi in C++ using MPI, test it out, and make sure it runs. Okay. Now, because you're doing asynchronous programming, and various processors and nodes can have like different timings, you want to have really strong ways of ensuring that the communication is happening. It's not going to get locked waiting for something to happen or have these dependencies. Now it's going through, and it'll probably say like, hey, I already have some code over here, but let me see if I should write it again. And, it's going through all of the motions in terms of coming up with its, task list and its implementation plan. And there you go. So it's sort of generated some code. It's made some changes from, I think, what was there initially. And what you can see there, it's actually running the code. It's compiled it, it's running it, and it's making sure that everything works and there aren't any deadlocks and so on, because that's typically the problem that you would have. Now, I could take this to another step and say optimize it for a particular architecture, or if I want to change the number of ranks to however many ranks that I need in order to be able to run this particular task efficiently, I can do that. But let's move on to something a bit more interesting. All right. So, as I was coming up with problems that I wanted to demonstrate over here. Now, this one, unfortunately, took me like 20 minutes to get all of the code in place. So we're not going to do everything from scratch. But the inspiration for this problem came from a computer science course that's taught by, hang on, I am going to I want to share something because this is a professor at Texas Tech, and it's Dr. Scott Franklin, who teaches this scientific computing programming course at Texas Tech, and he has a number of really interesting problems that he goes through, and this is really designed to help beginner programmers understand scientific computing. And as I was going through this, looking for what kind of problems can I do, and and he talks about this really cool project where you see over here, and it's really about targeting for artillery practice, and he felt it was a little too grim, so instead he changed the topic to dodgeball aiming. And as I was thinking about that, I was like, okay, cool. Well, dodgeball, that's really interesting. Now, if you look at a typical dodgeball team, there's lots of different players, different strategies, different levels of experience. And I felt that that would be a great example for having different agent strategies. And you can do a simulation which does all of these things, and then you can rank which is the best strategy. And then I added movement of the different players and so on. So let's quickly walk through that. I'm going to show you the prompt I used, and so okay, so the prompt I used, and again, this is multiple prompts, but let's walk through them. And my initial prompt was, I want to create an interesting demo about what is the best strategy to aim the ball in a game of dodgeball. I want you to create an animation that has several moving targets that we can test out our strategy. Now, sorry, in case you can't read it, let me make sure. Oops. That has several moving targets, and we can test out our strategy. Use multiple agents, each with a different strategy, and let's pick out the winner. Now, as I mentioned earlier, it took me like a good 15-20 minutes to get everything running, and it made some mistakes along the way. The UI wasn't working, and so on. But and rather than sort of make you wait whilst it's doing this, what I do want to do is just show you the end result of this game. And this is what it ended up being like, right? Now, again, this is not something I would have been able to do in 20 minutes. I don't know very much HTML programming or JavaScript programming or anything of those sorts. So but it produced this interface. It produced, everything that you see over here. And what you see on the left-hand side, what I'm sort of referring to over here, is the different agents. Now, each one of these agents has a different aiming strategy. You've got some obstacles. These are the targets, and just to make it a bit fast, let's start the simulation and let's ask it to play. Right? Again, it wrote all of this Python code, and you can see it's, each of these agents has a different strategy, and they're trying to hit as many targets as they can. And you can see the real-time score that's happening over here. As you'd seen, like in any kind of a true simulation that you'd have done as part of your coursework or your day-to-day work, you're doing these simulations and trying to test them out. And here you're pitting one agent strategy against another one, and you can see that, right? So we can see, like, Blaze uses a direct aim strategy. I know it's a bit small for those of you who can't see. Each one of these agents has like a different approach. Viper has a linear intercept approach. Oracle uses a Kalman curve. Vortex uses a tactical trap. Shadow uses a neural feint. And each one of these things are trying out various approaches. But let's see, and you can see, like, Blaze is really far ahead of everybody else. And when I click on, who is the trophy, well, we set like Blaze, right? So it had a hit rate of 42%, 3 eliminations, 1325 is its total score, and its algorithmic superiority breakdown is, direct line of sight aiming. It took the crown through sheer rate of fire and precision against stunned or clustered targets, right? So again, if you've got a problem that lends itself to this kind of a multi-agent strategy, it's amazing, how you can test it out really, really quickly. All right. All right, let's move on to our next one. So the other problem, and this is, again, this is really dedicated to Jay because he is an astrophysicist and he asked me to do this in particular. And this is, the three-body gravity problem, right? So for those of you who are not familiar, it's from Newtonian physics, we can solve, the place and location of two bodies, perfectly. Well, a little bit of, like, quantum mechanics and so on. Especially with, like, the retrograde sort of thing of Mercury. But, largely speaking, you can do that with, for two bodies. The moment you introduce three bodies into the problem, it gets really, really hard. So, and this is what I was trying to do. And this is a great demonstration of, of how you can actually see this in practice. So, and my prompt is, I want to demonstrate why it's hard to mathematically solve a three-body problem. Create an animation to show this. This is literally it. And again, this it took a few minutes to do it, but let's have it do it anyways. Let's have it do this in the background. And whilst it's doing that, I'm going to move on to another. Oops. I think okay. So let's have it do this again. All right, so we put it into our prompt, our agentic prompt. It's going to, like, figure out what to do next. Now, whilst it's doing that, let's move on to something else. Okay, so this one is another interesting one where, again, the very first step when you're sort of researching a problem is you're looking at literature review. And the prompt, and the particular problem, I was looking at, and again, this is a friend of mine, was asking me if I knew about a correlation between earthquakes and lunar cycles. And, is there any data to be, that sort of either proves or disproves this? So I put it into my prompt. But but what I also asked is, I want to do some literature review. And if you have any data, I want you to reproduce the data from those papers. Again, that's my prompt. I put it in, and it's trying to do a few things. Now, so what I'm really trying to demonstrate over here, again, through all of these different examples is, this is why the IDE version of Antigravity is so powerful, because you have this one workspace that you can sort of, it's isolated to all of the topics that you are working on. You can write code, you can display the results, and so on. And oops, okay, so here's a great example. Now, as it, was going through this prompt and trying to do whatever it needs to do, it's saying it doesn't have Python. And it's asking me, go ahead and install Python. So I'm like, sure, why not? Let's go ahead and install Python. So now it's doing that. Now, what you probably can see, but and let me make it just a tad bigger so you can see it better on your screens, is it has spun up a number of different agents that are doing literature review. It's got a skeptic researcher, it's got a geophysics researcher, and so on. So now it's produced all of these different agents that are looking at papers. I think it's found an interesting paper, and it's trying to build some code, and it's doing some interesting things now. Again, so sure. Again, as I mentioned, it's asking you for instructions along the way. And what you'll see is, it'll try to do stuff. If it fails, it'll try to fix that error, and so on. So it'll go through all of those different things. Now, let's see what it's doing. It's produced some Python code over here. Clearly, it's found some data from, earthquake.usgs.gov, federal
Oi,
agency.
gente. Yara por aqui. Em que eu posso ajudar vocês nessa conversa?
All right. I think I hear somebody speaking. Yes, thank you. Oops. And it's still working, and it's exploring all of these different agents as they're conversing with each other, challenging each other, looking for correlations, causations as much as possible. And it's going through some interesting, ways. It's doing the literature review. So, and one of the challenges with doing these demos is so much is happening in the background, right?
Yeah.
And it's really hard to show everything that is happening. And so that's why I encourage all of you to sort of try this on your own. Download it, try it, and you'll see it's really not that hard. And again, so typically when you're trying out new technology, the biggest problem is when you run into an error or a problem, right? The best thing is Antigravity has this already, sort of built in. You can ask it like, I ran into this problem. What do I do? How do I fix it? Well, guess what? It'll tell you how to fix it. So, you've got that built-in support doing this. So now, okay, so it's produced the results of this. Is there a correlation between earthquakes and lunar cycles, right? And it's done an extensive literature review. It's gone through the physical mechanisms, studies supporting a correlation. It's listed out the various papers, studies disproving the correlation. So it's, And ultimately, it's come up with its own sort of conclusion, but it also has some empirical validations, and this is probably what it was writing that Python code in order to be able to do, right? So, okay, so now whilst, we were doing that, let's go back to our three-body problem that we were doing earlier, and let's see if it has produced.
And then just so you know, we only have a few minutes left. I want to make sure.
Right, okay, I just want to get through the three-body, and then, we will call it a day. Okay, all right. Could we? Okay, so it's done something, and it's asked me to it's produced the Python code which is going to do this, and it's okay. So what I'm going to do this really quickly, and Jay, as soon as I'm done with this, I will stop. So, oops. So it's generated a visualization of this, and it's asking me to go to my browser. So we'll come back to this one. This is an earlier visualization that I did. Oh, I guess it's redone it. Okay, all right. So now, okay, yeah, this is the new visualization. And it's got these three-body problems, it'll show you these different things. So let's speed it up a bit. And you can see the three different bodies, how they interact, and so on. And it sort of goes through in a very step-by-step, almost like a tutorial of to help you understand why three bodies, solving three bodies is really such a challenging problem, and there's lots of very interesting mathematics behind it. You've got like 18 variables and not enough equations and so on, and it goes through all of these things, and you can have different starting conditions, order versus chaos. You can change, I believe in this version, I don't know if it's there, you can change the mass of the different bodies. I think I had to add that as a requirement in my earlier thing, but again, it's it produces all of these really interesting solutions to problems that in the past would have taken you days, if not weeks. For example, like for me to do something like this would have taken me like days, because I don't know how to program on the web, as I mentioned earlier. All right, Jay. So we've got more demos, but I did want to see if anybody in the audience had a quick suggestion of a problem we can try to solve whilst we try to wrap up in the next 5 minutes.
That I'm going to stop you on that because we only have a few minutes left, and I want to make sure we get to some of the questions. It's a lot of questions submitted.
Okay, all right.
Let's rapid fire. But Mary,
right.
If you could, everybody give Adnan, please, a round of applause. That was a great presentation and courageous set of demos online. So thank you for doing that. Real quickly, Mary, can you put up the slide for the next event and the Chicago workshop? We'll show that quick, and then we'll get to questions on this. I just want to make sure we make time for that. And for the first time ever, we'll run a little bit over the hour for people who want to stay for the questions. But Mary, I want to make sure we show the next two event slides first.
Yeah, I'll get that up in 1 sec.
All right. So I'm going to start getting ready for the questions here, getting ready to ask them. And while Mary's pulling it up, we'll knock out a couple real quick. Is Gemini/Google LLMs the primary tool used by Antigravity, or can you add others? And Adnan actually showed how to select other models.
Yeah, you can add whatever model you like. You can even add your local model if you have that running over there. So
I want to remind everybody we have a great session coming up next week on using Cluster Director. This is Google's high-end technology for managing clusters in Google Cloud. And so you can manage a cluster that acts like a persistent on-prem cluster in Google Cloud using this. You can also manage just the login nodes, spin down all the other compute nodes, and then rapidly spin them back up, GPU nodes, CPU nodes, whatever you happen to need at the time, while maintaining a persistent essentially login node, you can use and then release other things. It makes it a very cost-effective way to get what you need when you need it, especially when combined with DWS, which we'll talk about too. So Cluster Director is really, I think, a amazing capability for cloud computing. We also have a great workshop coming up in Chicago next week and some great future week sessions. And I hope you'll join the website so you can get email updates on things. With that, Mary, we can take the screen off and let's do questions for as long as people are willing to stick around. For those who have to go, we understand we always end on time. Thank you for tuning in today. We'll hope to see you next week. For those who can stay a little bit later, because we had so many great questions, let's jump into it, Adnan.
All right.
The next one is, how fast are credits used? Is a paid plan required?
I would say yes. And, you know, because you have these agents that are doing fairly complex tasks, they will use up your credits really quickly. And so, yeah, I would highly recommend a paid plan.
Yeah, my view on that, we all, flinch a little bit at subscriptions because everybody wants us to pay for subscriptions, and AI subscriptions cost more than, Apple TV Plus subscriptions. But as a friend of mine once put it, the subscription cost for AI plans is so much less than the cost of hiring a collaborator or coding program or junior programmer, all of this, that he pays for plans from all of the providers himself. And he says it is absolutely worth it to do it.
Yeah, and it's a variable expense. You don't have a salaried employee. That might make me unpopular, but yeah, but
that's right. And they never complain about you as a boss.
Yeah, right.
Deepak asks, how good is Antigravity on Google's Chrome OS?
Good question. I haven't tried it. I mean, for the most part, since most of it is running in the it should be decent, I would say. I haven't tried it, so I'm speculating at this point. So I don't have a definitive answer one way or the other.
We've only thought about downloading the clients for Mac, Windows, and Linux. That's a great question. We'll have to look into that, and let's answer that one in 4 weeks at the next.
I will do that.
Antigravity. Let's do that. Next question: how to request new features?
Good one.
I've never looked in the Antigravity app. Is there a way in there to?
I am going to look. I am going to look, but let's get through the other questions and
let's do that. Will Antigravity work offline?
Some features will. A lot of the agentic stuff won't, because okay, let me qualify that. If you do have a local agent and it's running on your system, it'll work, I guess, offline. But if you are using any of the cloud-based AI agents, then no.
Yeah, maybe if you download Gemma 4, it might. But the problem is every new model is better at coding than the one before, because all of the providers are focused on coding right now. So the latest models are going to work best, and they're usually cloud-based first before they release the a smaller open source one or open weights one. But the answer is yes, if you're willing to download a model. Let's see. Utara asks, is it possible to set token usage cap before running the query based on the token consumption velocity? Ooh, that's a good question. Most of us just run out of tokens and we get caught off guard.
Well, you know what happens, right? When you run out of tokens, you are downgraded to the next model that you have tokens available for, and it's usually like a previous version, like from 3.1 to like maybe 2.5. But there was the previous question. I think we skipped. Like somebody asked which model should they use, like 3.1 Pro, 3.1, 3.5 Flash, and so on. So typically, if this is my sort of like philosophy, is that if I need something that is a lot of research, for example, like that correlation between lunar cycles and earthquakes, that to me was a deep thinking problem, I would go with the Pro sort of model. But if it's something that it can answer relatively quickly, or I need an answer relatively quickly, and I don't really care too much about the accuracy, then I'd use the Flash.
Got it. Yeah, that was you answered a question I was just about to ask about choosing between the models. Actually, the question is phrased as, how would I decide between using Gemini 3.1 Pro and 3.5 Flash? I would bet in most cases you're going to get a better result for coding and use less tokens with 3.5 Flash, because the upgrades in that model largely focused on coding and reasoning. So 3.5 Pro, it's not quite out yet. I know we announced in April it would be out in June, and I'm well aware of the fact that today's date is July 7th. So I don't have any extra inside info other than I hope that it's imminent, but 3.5 Flash has extra coding reasoning in it. And so 3.5 Pro, when it comes out, certainly will. And then that will be a tough question, when to use 3.5 Pro versus 3.5 Flash. But 3.1 Pro versus 3.5 Flash for anti-gravity, I'm willing to bet most of the time you're going to get better results with less tokens at 3.5 Flash. Someone wants to hear more about context rot, even with implementation plan and agent instructions tightly coupled. That's the first question we've gotten in this community about context rot. Do you want to say anything about that? Is it a issue when you've got an implementation plan and agent instructions tightly coupled?
So, okay, I mean, what I will say is, and Jay, you know this, like sometimes when you have, you know, a very long sort of like prompt and you try to like, you know, have lots and lots of context, then you do have it sort of changing parts of code that you asked it explicitly not to change, or you have to kind of remind it. But what I didn't cover over here, and this helps to an extent, is the rules and the skills. And, you know, these are like text files that you add to your workspace, and you say, you know, these are the rules that you have to follow, and the skills are some of the things that you can add. For example, like, you know, how do you look up, like, you know, information sites like, you know, news archives or you know, X archive and things of that sort. You know, you can give it those skills. Having that helps, because if it has to figure out everything by itself as you're, you know, based on your prompt, then I see the opportunity for more context rot. But I haven't seen it. Again, you know, all of these demos were so short,
right,
that, you know, so generally what I have noticed personally is, like, if it's too long and there's too much context, I just start a new chat window and I start over there.
I see that we're down to about half our initial attendees, so I am going to stop the Q&A here so that we can save these questions, and then maybe we can prepare a document with answers to these other questions that we share at the August 4th session, so we can both save time and more people will see all of the answers to these. So let's do that. Come back on August 4th for part 2 of anti-gravity, when Adnan will talk about the CLI and how to use it in some different ways, as well as the SDK and science skills. So thanks everybody for joining. Let's give Adnan another round of applause. That was a great session. I predict lots of anti-gravity downloads after this session ends today.
All right.
Thanks,
Thank
Adnan.
you very much, team. All right.
Everybody have a great week. Bye.
All right. Bye-bye.